right. So thank you, Nico, for taking the time to chat with me today. I know that you're busy, and this being a short week makes everything a little bit more compressed. So I appreciate your time. Why don't we start with maybe describing what it is that Kairos Power does, and then we'll switch to your specific role and what your team does.
Absolutely. Well, thanks, Javier, and thanks for this opportunity.
Mm-hmm.
Yeah, why don't I start with our mission, which is really what drives everything we're doing at Kairos, which is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment. This is our mission. How we intend in doing that is through commercializing a new kind of nuclear power reactor. And this is the sole focus of our company right now, is all of the technology development that will eventually get us to that advanced reactor.
Yeah, when you go through your website and now that we at JKI got to know you guys better, it's just impressive what Kairos is doing and what the overall mission is. So once we actually started working with you guys, we were super excited to actually work with a company that is making a tremendous difference and has really high goals. So you're the senior manager of engineering testing, and maybe could we go into what your team does and the different things that you're trying to test and validate?
Absolutely. So one thing to note about Kairos is that our design process, since really we're in the business of trying to develop a new design for a nuclear power plant, our design process is rooted in iteration cycles between planning, building prototypes, which is really important, testing, and then learning from that and kind of iterating through different concepts, from small scale simplified component tests all the way up to what would be almost full scale and more integrated prototypes. So in that context, the testing aspect of the work we do at Kairos is really important. And the company, very early in the process of developing the business, has made a lot of investments into our R&D facilities, where we actually have laboratories now in California, and also standing something up in Albuquerque in New Mexico, where we are running a lot of tests to prove different aspects of our technology. The different areas that me and my team are working on are focused on two main aspects. One is what we call validation testing, and these would be tests where we collect extensive sets of data, physical data, temperatures, pressures, flow rates of fluids in the systems that would eventually be used to validate computer simulations to demonstrate the safety of our reactor technology. So that's one aspect, is validation testing. The other aspect that our teams are also heavily focused on is what we call component development testing. The plant that we're trying to develop has a lot of new features. We have lots of new systems that have never been built really, or at least never been demonstrated at scale in the past. And so we have to do a lot of design and testing at different scales to show that those different systems work as intended, can work for extended periods of time. And so those tests are more focused on the mechanical behavior of the systems, and also health monitoring and things like that, to make sure that those systems can operate in the long term.
Right. So so you mentioned validation testing and then component development testing. So for validation testing, is it also gathering data so that you can show to regulators and whoever needs to regulate the final product?
That is absolutely right. So I will say, just like everything we do, we have different iterations. Right now, the main thing is proving to ourselves that the simulation tools that we are using can be trusted. Also support the team that is developing those tools to implement new correlations, new physics. But in the end, exactly like you said, the goal is to build a reactor that can be licensed. The nuclear industry is a regulated industry, and there is a US Nuclear Regulatory Commission that would eventually have to license our concept and the fact that we can build it and operate it. So all of the data that we would gather through those validation tests would be data that they can eventually look at and ensure that they match what our predictions were saying, and that the concepts are indeed safe to build and operate.
Right. And going to the component development testing. So what you're saying is, of course, a nuclear reactor is, and just all the control around it is very complex. So what you're doing is doing modules and smaller systems. You test them individually, and then eventually you start putting them together into building the big system. Is that correct?
That's right. No one can claim today that they can have a great idea about a nuclear reactor and just go straight from paper to one day building it and operating it, and everything is just going to go fine. There is a lot to learn along the way. And what we do, these are really the building blocks that you mentioned. So we start at the component level, and even for individual components, we don't necessarily start with the full scale component. We would usually start with a reduced scale prototype that we would build and operate in our lab, very often in simplified conditions, lower temperature, just a room temperature water environment is something that we deal with on a regular basis in the early stages, just to demonstrate that the system works as intended. And then, as we demonstrate that things are what we want them to be, we would slowly scale up individual components and also start integrating them all together. So not just the physical scale of, say, one pump or one heat exchanger or one control system, but also how they interface with each other, how we can mount them all onto one unified system, and how eventually all of those systems would talk to each other when they operate in the actual plant.
Right. One of the things that impresses me about just the way that you guys are thinking about this is you're basically developing a new nuclear reactor in an agile fashion, right? Which is, I mean, we hear that all the time for software, but I don't know if that's typical of the industry.
No, I will be honest, it has taken us a little while to really understand what that means for us. Agile is a term that is everywhere in the software industry now. Right. And that works really well when you have a very low cost of change where, you're going to test a new feature, push it onto your customers, and after a week, if they don't like it, you just scrap it, right?
Right.
We can't really do that, obviously. We're dealing with hardware, and what customers want is even that is a little bit of a loose term, and a lot of times it's just what internally we know that we have to develop. So it's a little bit of a different approach, and it took us, as I said, a little while to understand what it means. But the fundamentals of Agile are there, and it is the fact that we have much faster iterations between different concepts because we're working at smaller scales and with individual components compared to what the industry has historically been able to do. And so for any given system that we've been developing so far over the past couple of years now, sometimes we've been through, 10, 15 different prototypes that we slowly optimized to exactly fit the function and the requirements that we needed. And feed that back into the design, into the simulation world, to better understand how we can optimize the systems. That's really important for us.
Right. That makes total sense. And the question about the technology is what's different about the technology that you guys are developing? And I know you've mentioned maybe low cost and just faster to deploy. But can you talk more about the technology?
Yes. I'll start at the high level that you just mentioned, because this is really important. We started the conversation with our mission, and that's to enable the world's transition to clean energy. The reality is we can only expect to compete in the landscape of energy production in the US and eventually maybe worldwide if we can be cost competitive with existing sources. Right now in the US, there has been a boom of natural gas power production in particular since the early 2000s. This is really what we intend to displace, and this is what we have to be competitive with. And the costs are really low right now for natural gas. This is why everyone is building it, especially in the US. And the question is, how can we compete with that? That gets us to some of the specifics of our technology that are really important to differentiate us from other technologies that have not been able to compete with natural gas. The fundamentals of our technology that are different from existing nuclear lie on a combination of the fuel that we're using, the coolant that takes the heat out of the fuel and eventually transfers it to a power production system, and overall our approach to licensing for the reactor technology. The fuel itself, in more conventional nuclear power plants, comes in the form of static fuel rods. They're very long and slender rods that contain the uranium oxide material that generates the heat. And in our case, we are using hundreds of thousands of small spheres that are roughly the size of a ping pong ball that travel through the reactor constantly, that generate the heat and that get recirculated instead of being static in the reactor. The fact that they recirculate constantly means that we don't have to have forced outages of the plant to replace the fuel, because it's constantly replaced.
Right.
But the other really important aspect is it can go to really, really high temperature without failing. It has been demonstrated it can withstand temperatures up to, we work in degrees centigrades, 1600 C, which is much higher than the current fleet. So that means that from a safety standpoint, we can withstand a lot of events without risking damaging the fuel, which is where most of the radioactive material is contained. In addition to that, the coolant that we're using, which is the fluid that travels around the system and that carries the heat around, is a molten salt. So if you were to see it at room temperature, it really looks like, table salt, but you heat it up above 460 degrees Celsius, and it melts at that point, and it kind of looks like water. It has a slightly different density and viscosity, but it's a transparent fluid, and it has again a very high boiling temperature. So we can push our system up to higher temperatures than what conventional nuclear power plants have been able to do so far, which is really great for safety, but also really great for efficiency, because the higher the temperature, the higher the efficiency you can drive from your system. From a cost perspective, what is really interesting with our system is because we operate at those much lower pressures, essentially close to atmospheric pressure, instead of the pressurized water reactors that operate in the current fleet of nuclear reactors.
Right.
We have much thinner walls for all of our structures, and overall material count is much lower. So what is driving really, really high capital costs in the light water reactor fleet that exists today in the US and elsewhere in the world gets much simplified, because we have much more compact systems with a lot smaller amount of materials that go into it, which directly drives the overall cost of building those systems down.
Interesting. That's really interesting. And you mentioned a couple times the idea of licensing. So my question is about like the business model. And so what's Kairos's business model at the end of the day?
Well, we are in the business of commercializing nuclear technology, and that is for the reasons that I mentioned a couple of times, to enable the transition to clean energy and non-CO2 emitting energy generation. The licensing that we talk about is really the regulation part, which is licensing by the Nuclear Regulatory Commission.
Mm.
But our own business is to develop and sell the technology itself, and eventually be able to put electrons on the grid. So partner with whoever that takes to be able to generate electricity for the U.S. power grid.
Okay, that makes total sense. And I'll like to now move into the collaboration with JKI. So Kairos Power and JKI have been working together now for I want to say close to 2 years.
That is right.
And
I checked back in my email, and I think our first exchange was in May of 2018.
Yeah, you're correct. And I remember at that point, you guys were still only in Oakland, right? And we went to the office and had a couple of good discussions. But maybe I'll summarize it in my perspective, and then I'll love to hear your take on the collaboration. But National Instruments, who manufactures the PXI controllers and some of the data acquisition cards that you guys use, recommended JKI as a potential partner. And then JKI came in, saw your system, interviewed your team, understood what it is in terms of data acquisition that you were trying to do, recommended specific hardware, and then design the software in a way that we could get you something quick and kind of in the same fashion as you guys operate, do agile development and give you more features just as soon as possible. And then with the final goal of making Kairos self-sufficient in terms of being able to maintain and develop new software. So that's kind of my take, but I'd love to hear your take on it.
Yeah, no, that is right. So if I were to go back through the history of Kairos, which is really important to understand how fast we're operating relative to the rest of the industry. We were founded in late 2016. The team started to grow through 2017, and we started looking for lab space in the San Francisco Bay Area. Which is where we were located in Oakland, as you said. And we found a lab, or I guess back then it was just an empty hangar that we wanted to turn into office space and lab facilities, because we already knew that we wanted to run those tests that I mentioned, both on the validation side and the component development side. We knew roughly what the classes of tests should be. We didn't have all the specifics of individual test plans and objectives, but we knew that we wanted to get into the business of the technology development for that reactor, that new reactor class, without having to go into the business of developing data acquisition systems and developing data acquisition software and all of that. So in 2018, we started looking into what hardware and software we could use to operate all of those tests, or from controllers to sensors that we use to collect data and all of that, and reached out to National Instruments because we knew that they sold very common and reliable hardware that's used throughout the R&D business. And we really were looking for a partner to help us develop that hardware and the software that goes with it. We got in touch with you, and as I said, I think May 2018. At that time, we were already wrapping up all of the works that had to be done on the hangar that hosted our office in the lab space. And we moved into that space in September of that year, September 2018.
Right.
And I would say just 3 months later, in December of that year, we already had our first test system, which was a component development test back then, that was up and running and using the hardware that JKI had recommended and using the software platform that JKI had been developing for us. So that was a pretty quick turnaround. What really helped in that process was that your teams working with our engineers had a good understanding of the building blocks that were going to make up the final systems that we wanted to operate. And I think what helped a lot was to be able to build things up in kind of a modular fashion, where we had this first test system delivered and operating that was using a few of the building blocks, while in parallel, your team was helping us develop the rest of the building blocks that would eventually allow us to operate any tests that we're currently running in our lab, essentially.
Right, right. And for your specific system, we use a LabVIEW framework that we call RAFL, which stands for Rapid Application LabVIEW Development for LabVIEW. And one of the things that early on, both your team and our team identified was we wanted to give your team just as soon as possible the ability to create and customize tests. So we use one of our libraries that exposes basically the RAFL LabVIEW framework to Python, and then using Python as the scripting language. And I know that that's one of the things that, as you were saying, allowed us in a few months to have your first system running and allow you guys to just start testing and trying different things. And then the next system, you guys already had feedback, and we already knew that there were things to modify, and then just kind of in an iterative manner, right?
Yep.
I don't know if you have any thoughts on the Python combination with LabVIEW.
Well, I think what was really useful for us, again, we did not have that many LabVIEW experts in-house. We were really in the business of developing our technology, and whatever works to control and collect data would be great. One thing that's pretty, I guess, pervasive throughout the company, though, and lots of engineering companies today, is something like Python and scripting in general for automation of tasks, whether it's on our software development side to run various cases in our simulation tools, or again, the hope was that we could use something similar and scripting in the context of executing tests with a lot of different conditions and essentially automating the test matrices that we wanted to go through. Right. And this is exactly what that integration that you guys helped us with enabled. That pretty much all of the engineers on the team were familiar with Python, less so with LabVIEW, but they could very quickly run through, a for loop of 100 different, or I mean, eventually it could be thousands, but the limit is the physics of cases on those systems. Essentially, press start, just make sure that they attend to the facility itself to make sure that everything goes fine, but not have to turn the knobs themselves, like might have been the case a couple decades ago, or maybe even a few years ago, but just automate the whole process and let the system run, collect all of the data. And the nice thing is we are also using Python scripts downstream of that to analyze the data and compile it into a form that is useful for our engineers. So the integration allowed us to use the same tools through the life cycle of a test, instead of having to jump back and forth between 3, 4, 5 different tools.
Right. That makes total sense. And I to me, there's a big advantage, as you were saying, of using Python in different ways, and there's specific technological advantages as well, but just the ability to find people that are familiar with Python, I think that's a key aspect, and why we build this technology and we deploy it on a regular basis, just because it suddenly opens up the door for customization, and you don't really need to call JKI for that customization, which is it's always good. That being said, part of the plan since the beginning was to train your team into how to actually modify the LabVIEW aspect and create your own custom modules and subsystems. And we've I would say we're already in that phase. We've provided a few training sessions. So I'm just curious of your thoughts about that part and just the transition and why that's important for you.
Yeah, I mean, the way that went was ever since we started our collaboration, a few of the engineers on the team were deeply involved with the development that you guys were helping us with. We're really learning through your standing up of all the capabilities. We were also learning how things were set up and kind of how the different modules were talking to each other and things like that. There was training, both online training and in-person training that your staff gave to the team that helped really get us familiar with how things are done, and how they were set up for us, but also how we could evolve from what we have to what we might want in the future. And I think the beauty with it is, I'll go back to the term I've used before of building blocks. The same way we're using those building blocks for going from component level to scale up and integrated level on the hardware. We have the same building blocks set up in the software, where we know that we will start with handling maybe one specific type of sensor here, one specific type of controller there, and the next facility we might use 3 of those sensors and 2 of those controllers, but the building block is the same. So you essentially copy paste. I mean, I might be oversimplifying here, but it's almost as simple as this. And all of the drivers, all of the settings and everything that you would always have to redo essentially if you were dealing with the low-level LabVIEW integration. Here we have this kind of wrapper that allows us to use those building blocks over and over again. And because we try to standardize our test equipment as much as possible in the lab, it means that once your team had helped us with, say, the first 4 or 5 iterations, we are now ready to go with the next 10, 20, 30 with very minimal support.
Right. Yeah, I wanted to ask you specifically about your experience at Kairos, and I know you were mentioning that you were the first employee in one of our conversations.
Yeah, John, that's right. So the 3 co-founders were all university researchers and decided to found the company in late 2016. And I knew them quite well. One of them was actually my PhD advisor at UC Berkeley. And as soon as I knew that they were trying to set up a team, I was really excited to join and be part of that effort. So I've been there since January of 2017. Okay.
And now Kairos has, I believe, more than 100 employees?
140, I think, last time I checked. Yeah.
Wow. So what has that transition been like for you? Or just to see it from basically, you were saying 4 or 5 people to now 140?
Very exciting. I mean, obviously, we have a lot of technical, challenges to deal with and to tackle. The team is not just the engineering testing team that I'm lucky to manage, but there's also there's other aspects of our testing program that I'm not directly working with, but that is also important. That touches other challenges related to the handling of the materials, the molten salt itself and its chemistry. We obviously have a lot of designers, mechanical engineers. We have licensing folks. We have business people now. We have obviously some admin support. It's just seeing all of those pieces come together and all converge to one shared mission that's really dear to all of us is the most important thing. And it's been very exciting since the beginning. We started in small office space. We started with 1 office in Oakland, then we had 2 offices in Oakland, 2 blocks apart. And now we have our beautiful Alameda facility that has our office space and our labs. We are now setting up a R&D center in Albuquerque, New Mexico, as I mentioned, which is where we're going to be working with larger salt systems. And we also have an office actually on the East Coast in North Carolina, which is mainly where our licensing folks are and who interface with the regulatory commission in DC. So.
Oh wow, interesting! I didn't know about that last one. Was your plan always to go into the nuclear energy space? I know your PhD is in nuclear energy, right?
Yeah, that is right. I mean, always. I will say, so I grew up in France. France has more than 70% of its electricity coming from nuclear. So I had some familiarity with the basics of the technology from a young age. I studied topics related to energy through undergrad without exactly knowing what I would do next. Nuclear was really attractive to me from the I guess the non CO2 emitting aspect for helping with combating climate change, and also just the I guess the engineering challenges associated with it. So as you said, I decided to come to the U.S. to attend the PhD program at UC Berkeley in nuclear engineering. That's how I got to know actually all three at some point in my PhD path of Kairos co-founders. And the technology I worked on back at Berkeley was the technology that led to Kairos. I spent a little bit of time in the solar industry, actually, for a little bit under 2 years. Again, driven by the whole, non-CO2 emitting energy source, and trying to understand what that takes. But by the point Kairos was ready to happen, I was more than happy to jump on and go back to the technology that I had been working on for my whole PhD.
Right. Yeah, I was going to ask you about that company, because I know it's a company that now was acquired by SunPower, I believe.
Yeah, I mean they got acquired by SunPower just maybe 1 month or two after I joined, so I didn't live much of the startup life there.
Okay, I see.
I've seen a lot more growth through Kairos than I did back then.
Okay, but it seemed like you had renewables and renewable energy in your mind from early on.
And clean energy in general, and anything that can help with climate change, for sure.
Right. I want to end with one last question, and maybe the toughest question, but what do you think is the future for just in general power generation in the US? And maybe you can have your take at what you would like it to be, but I'm curious on your thoughts on that. Obviously, you're in the industry.
Yeah, I mean, predicting the future, especially in the energy business, is close to impossible. If for people listening in that would be familiar with energy markets, I mean, there are futures markets in the energy business that are even an hour ahead and that manage to be wrong in what's going to happen in an hour. So I'm not going to try and predict what's going to happen in the next decade or more. What I can say for sure, and what drives everyone who works at Kairos, is that there is a clear issue with climate change. That's a global issue, but the U.S. has really talented people that can help with that problem and have to start thinking about how to tackle it. And in that context, I think technologies like what Kairos is trying to develop, that would be clean energy for the long term, is what we need. Not just for the U.S., but really for the world. Starting with the U.S., our goal is to be able to displace as much fossil fuel generation as possible, and that's going to be the starting point. But eventually, this is really a global mission. Right.
And maybe I'll just add another question now that you mentioned that. Anybody that is interested in just getting in the industry, or just basically, as maybe if you think of you, I don't know, 10 years ago, just any recommendations for them?
Well, it is an extremely diverse industry in terms of backgrounds. It's amazing when you look at really what people have done before they joined Kairos. We have lots of engineers, obviously, but within engineering, we have mechanical engineers, chemical engineers, systems engineers. We have people that are more on the business side, that have seen companies, grow, and that's really what we're trying to do as well. Communications people, policy people. So there's no shortage of area that can all converge into what it takes to make the nuclear industry successful. So I guess my advice, that is not just in this context, but to anyone, would be just do something that you like and you think you can be really good at. We are obviously trying to tackle one of the most complex challenges of our time, so it takes a lot of motivation and a lot of hard work. But there's so many different paths that can lead to it. There are nuclear engineers, that is a thing, but really for being a nuclear energy company ourselves, it's not like we only have nuclear engineers. There's really all sorts of backgrounds that can be really, really valuable.
Right, right. That's great advice. I appreciate it. And I want to leave it there. I truly appreciate your time and having this conversation. I look forward to continue our collaboration and just seeing more systems being developed and seeing just you guys continue towards your mission. I appreciate your time, and we'll chat soon.
Thank you very much.
Thank you so much.